This is an introduction to integration by substitution. I'm going to just dive in straight away with an example. So the idea here is a bit like the chain rule, but for integration rather than differentiation. Now with this thing here, if we wanted, we could expand this out using binomial expansion and get a quartic, which we could integrate term by term. So add 1 to the power, divide by the new power. But we don't have to. Here, just like with the chain rule, we're going to pick a substitution. I'm going to pick u equals, and then the thing inside the function, so the thing inside the bracket, 2x plus 5. Just like with the chain rule, we're going to differentiate this. So du dx equals 2. Right. This thing here, we're going to put in terms of u's. So this is the integral of, the thing inside the bracket is now u. So we've got u to the power 4. And we still had a dx there. What we want to do is we want to change this into u's as well. The way in is we're going to rearrange this so it's dx equals. Now it feels a bit bad at first when you're splitting these up. This is formally defined, but you won't formally define it until degree level. So just trust me, think of it a bit like a fraction, it will get you the right answer. And this is completely acceptable in the exam as well. So I'm going to times up by the dx. So I have du equals 2 dx, and then we could divide by the 2. So we have du over 2 is dx. Now this feels completely wrong, but it's fine. This dx we're going to substitute in for there. So we can replace the dx with du over 2. So this is the integral of u to the power 4 du, and then I've got to divide by 2. I can actually put it wherever I like. So I could put it over here, divide by 2. I could put it divide by 2 here, which is what I'm going to do. If you wanted, you could have brought it out as a factor as well. You could have had a factor of a half. Right, this thing is in terms of u now. So integrating with respect to u, we add 1 to the power, divide by the new power. So it's going to equal u to the 5 dividing by 5. So we've got a factor of 10 on the bottom, plus c. Okay, we're not quite done yet because u is just this thing that we invented back up here. We can put it back in terms of x. So we've got, open brackets, 2x plus 5 to the power 5 over 10 plus c, our constant of integration. Cool. I'm going to show you an example with limits on it as well, and it's going to be slightly harder. Here we go. So this time it's a definite integral, it's going between 2 and 3, so we're expecting just a number out. Now again, we're going to pick a substitution, so u equals 4x plus 1, du dx equals 4. Rearranging for dx, we have dx is du over 4. This thing here, I'm going to worry about the limits in a minute. Okay, this thing in here was just u, and it was square root of u, but square root is just to the power of a half. Just like in first year integration, we want to write these things as a power, so we can add 1 to the power and divide by the new power. Dx is du over 4. Du over 4. Now, our limits were to do with the x coordinate. We want them to do with the u coordinate because it's with respect to u now. When we change this, we're going to change the limits as well. So if x was originally 2, well, if we put it into this one, this is the thing linking x's and u's. If x was 2, 4 times 2 is 8, plus 1 is 9. That's the new lower limit. And the other one, if x was 3, 4 times 3 is 12, plus 1 is 13. Cool. Now we can do the integration. When I integrate, because it's a definite integral, we're going to have the square brackets. Add 1 to the power, that's u to the 3 over 2. Divide by the new power. Now dividing by a fraction, that's the same as timesing by its reciprocal. So that's the same as timesing by 2 over 3. So we've got a quarter times 2 over 3, which is 1 over 6. Because one of the factors of 2 cancels out with one of the factors of 2 on the bottom. If you want, you can have the plus c, but it's not going to matter because it's going to cancel out. And then we're going between 13 and 9. Putting these things in, we've got 13 to the 3 over 2 over 6 minus 9 to the 3 over 2 over 6. This one is actually nice to evaluate. but at this point I'd probably grab a calculator and work it out explicitly. Now you actually have a choice here. Instead of changing the limits from x to u here, what we could have done is at this point go back in terms of x here and then use the original x limits. It's actually completely equivalent and it's up to you how you go. I'm going to give you 2 questions to have a go at, one with limits and one without, and I'll go through the solutions to have a go at these. Okay, here you go. So there are 2 questions here. This one doesn't have limits, so we're expecting an answer in terms of x's with a plus c at the end. This one does have limits, so we're expecting just a number out. Right, over to you. Pause the video and I'll go through the solution. Okay, so on the first one, I bet u to be the central bit. I differentiated and I've rearranged for dx. So this thing is the integral of u cubed du over 3, which is u to the power 4 over 12 plus c. And then substituting back in the x, we've got this. X plus 4 to the 4 over 12 plus c. Right, next one. Okay, once again, I've got u equals the thing inside. Differentiating up and rearranging dx, we've got this. I'm also going to change the limits. So this, if x was 0, 2 times 0 is 0, plus 1 is 1. If x was 1, 2 times 1 is 2, plus 1 is 3. This thing here is going to be u to the power of a half, because square root is just the power of a half. And then we've got du over 2. Right. Square brackets, because we're getting a number out. Add 1 to the power, is u to the 3 over 2. Dividing by the new power, well, we already had to divide by 2. If we're dividing by 3 over 2, that's the same as timesing by 2 over 3. I'll put in an extra step there, and we'll do some cancelling in a minute. Between 3 and 1. Well, that thing there simplifies. The 2's cancel out. So we get u to the 3 over 2 over 3 between 3 and 1 and 3. Popping our numbers in, we've got 3 to the 3 over 2 over 3 minus, well, 1 to the power of anything is 1 over 3. This thing here, well, I can cancel out some of the 3's going on. That's 3 to the half minus 1, or if you prefer, root 3 minus 1. Done.